Welcome to PowerUp, a podcast show that brings life to some of the stories on power electronics technologies and products featured on powerelectronicsnews.com and through other Aspen Core media publications. In this show, you'll hear both engineers and executives discuss news, challenges, and opportunities for power electronics in markets such as automotive, industrial, and consumer.
Welcome to today's podcast. Today's episode is brought to you by our sponsor, Henkel. I'm your host, Alia Shokath, Editor-in-Chief of Power Electronics News. Power electronics is at the center of some of the biggest technology shifts of our time, from EV powertrains to AI data centers to industrial electrification. But behind every power module, there's an often overlooked material story that is just as important to performance and reliability. The die attach, encapsulants, thermal interface materials, and more are intrinsic factors that determine whether a module survives years of thermal cycling, high current, and demanding operating conditions. Today on PowerUp, I'll be joined by Dr. Burcak Conley, Head of Application Engineering for North America and Europe at Henkel, a company with decades of experience developing semiconductor packaging materials for some of the most demanding applications in the industry. We'll talk about what's driving demand, how packaging materials are evolving to meet higher thermal and reliability requirements, and where Henkel sees the biggest opportunities ahead. Listen in to learn more. Hi, Burcak. Thank you for joining me. It's very good to have you here. How are you doing?
I'm good. Thank you. Thanks for the invite.
So can you please start by introducing yourself?
Sure. My name is Burcak Conley. I'm currently VP of Application Engineering in Electronics Business of Henkel and responsible for North America and European regions. And my background, I'm actually a chemist by training, but I have been having 18 years of experience leading technical teams and taking early stage innovation into commercial success, of course, with our external partners. And again, great to be here today.
Well, thank you so much for that introduction. The power electronics industry, it's seeing a pull from multiple directions at once with a wide range of applications, including EV, AI infrastructure, and industrial electrification. What power electronics trends are you seeing today, and which do you feel are creating the most meaningful inflection for materials suppliers right now?
Yeah, very interesting questions. If we look at these mega trends, we see a couple of major fundamental drivers behind. For example, first of all, maximizing efficiency while improving reliability. Second, managing power density while minimizing cost and reducing the package size, especially in AI applications. And of course, supporting high thermal loads, which is a big challenge in this industry. And these application needs are actually very exciting opportunity for leading material suppliers like Henkel. So we're trying to come up with an innovative solution so we can help enabling these technologies with our materials. And when I look at where we are at this journey, Henkel's semiconductor packaging and material development clearly sit at the intersection of all these trends to support thermal management, electrical performance, reliability, with, of course, our global manufacturing footprint and technical support.
Well, thank you. So from what I understand, Henkel has deep roots in semiconductor packaging materials, particularly in wire bond. As power modules push towards higher thermal loads and stricter reliability requirements, how is this shaping what customers are asking for in terms of, say, die attach adhesives, encapsulants, wire bonding, and other packaging materials?
Yeah, you're correct. I mean, Henkel has been supporting wire bond packaging and die attach for more than 50 years, with some of our early products still actively used as the gold standard for reliability and performance in traditional die attach applications today. Throughout the years, we continuously invested in innovation to meet the challenging demands of this market. And to be honest, it's a very interesting time for us to be the leading material suppliers as we see power modules undergo further development and more challenges comes with it. And of course, more and more innovation is needed from us. And today, our customers asking for packaging materials with the capability to handle higher current density, higher operating temperature, higher thermal and reliability requirements, and all for a reasonable cost. And if you look at deeper, for example, in electrical vehicle industry, in DC to DC converters, with the adaptation of silicon carbide die to improve reliability, pressure-assisted silver sintering material is widely used today as a die attach. But after solving this reliability of die attach bond line, the wire bonding and base plate attachments become a bottleneck. So originally, aluminum wire bonding was widely used in power motors, but the high current density generates a lot of heat and induces failures. So therefore, different wire bond technologies are now being developed, such as copper clip sintering and copper ribbon on copper foil. And again, if you look at the bottom side of the power module, the heat sink and the base plates are often combined to improve the thermal performance and reduce the size and weight. Currently, these modules, which are soldered into a base plate, and it faces the big reliability and overall package thermal handling challenges. With that challenge, we are seeing our customers are actively trying to use sintering technologies to replace solder. Again, if you switch the gears, and same for AI data center with solder materials. So especially for vertical power module and AI data center, as you know, solder is currently used for inductor and component attachment. Yeah. But with the increase of current density, solder hits a limit on thermal conductivity and again, capability of handling the current. So our customers are actively searching for new solutions such as pressure-assisted sintering or pressureless sintering and high thermal paces to really manage this thermal conductivity needs. And last but not least, another great example is for encapsulants and molding components, as you highlighted. Silicon gel was widely used in the past in frame type of power modules, but could not fulfill the reliability requirements anymore. So again, the materials suppliers like us, new high reliable epoxy encapsulants is needed to address these technical challenges today.
Thank you so much for that. That was a very comprehensive answer. And maybe we could zoom in a little bit more towards sintering. You know, there's been a clear trend towards sintering, high temperature die attach, and materials that can survive more aggressive thermal cycling. And this is especially true because silicon carbide and gallium nitride devices can operate at higher temperatures than silicon. Where is Henkel focusing on its innovation efforts to meet these enhanced reliability standards?
Yeah, absolutely. I mean, the trends are very clear in the industry, moving towards high temperature and really pushing the reliability envelope for all of us. And these trends are a direct response to some hard constraints in design requirements. If you look at it with the move to wide band gap devices like silicon carbides and gallium nitrides, these devices are designed to run at high junction temperature of 175 and above. And these are the temperature where traditional solder materials starts to degrade. And if you look at the requirements of electrical vehicles, thermal cycling severity is getting worse, of course, due to the fast charging and demanding frequent on and off cycles, large temperature swings, creating substantial stress from CT mismatch as the die, substrate, base plate, all expand at different rates and leading the failure mechanism and in traditional solders due to the fatigue, voids, and delamination. And on top of these, heat flux and power density are increasingly sharply and creating the need to remove heat effectively from a really shrink footprint, resulting thermal and mechanical load being higher and higher on die attach materials. Again, this is a lot of information. So what does all this mean for Henkel and our innovation efforts? So going back to our key innovation efforts, we are currently focusing on sintering and high thermal paste materials. And going back a little bit of a recent history, Henkel launched the first pressureless and pressure assist compatible sintering materials back in 2009. And since then, we have been significantly focusing on pressure sintering materials for many years. And we have actually successfully launched several products to cover different sintering application, along with very interesting patented technology called PIPs, to allow us to develop high thermal and high reliable materials at relatively low silver content. And also recently, we also had a big breakthrough in pressureless sintering on bare copper surfaces. As you know, copper surface is very complex, and copper material for copper substrate used in different packages are very diverse. And Henkel developed a solution to really cover different copper surfaces while still maintaining the excellent reliability, which is a significant performance requirements for this technology. And again, all these provide a good pipeline for power module in data center as well as electrical vehicles. I also wanted to give some examples on the power module in electrical vehicles because we see more and more in the industry today. Henkel, we've been focusing on copper-based pressure assistance sintering significantly. We truly believe that copper sintering can provide comparable or even higher reliability than silver sintering in some cases, and even much more affordable cost, and especially for the copper-based plate attachment. And you know that silver sintering cost recently, silver materials has been significantly high. And today, our copper-based pressure sintering paste can be sintered actually at the pressure and temperature as a silver pressure sintering paste. And we see that reliability has also been proven in multiple packages to meet different customer requirements. I think this is a very interesting technology development.
Oh, thank you for that. So when you're working with power module manufacturers on new designs, what are the recurring pain points that you hear the most?
Yeah. So, I mean, if you look at power module manufacturers, they customize their module design and architecture based on, of course, their OEMs, their end customer needs. We totally understand that. And this often results in, of course, specific optimization and new package design architecture for cooling, die bedding, die layout that again requires specific form factors of high thermal sintering materials. But if you look more closely, the power module design development cycle is extremely fast and comes with many challenges. Our customers do not only need a material with high thermal and reliability performance, but also materials which can be integrated into their existing process or even compatible with the new design. And again, giving maybe some specific examples for many power module using gallium nitride, especially in data center, thinner die is the trend. It's basically the trend to further improve package thermal performance. And it's very challenging to use existing paste materials to bond 60 micron or below die. So therefore, our material innovation, along with close collaboration with the equipment supplier, is needed to optimize the process. And again, if you look at power modules in electrical vehicles and renewable energy, we see embedded power modules are an important development, directing the reduction of the size and package and further integration with other functions. And these are also clearly recurring pain points across these technologies.
It's very interesting. Thank you so much, Burcak. Last question for you. Looking across automotive, industrial, and data center power segments, where do you see the most significant growth opportunity for material suppliers over the next, say, 3 to 5 years?
Yeah. So if you look across automotive, industrial, and data center, Again, electrical vehicles, renewables, and AI-related applications on cloud and edge are going to drive the demand for foreseeable future. And the fundamental key requirements from the industry for power electronics packaging remains to improve power conversion efficiency, reducing weight, reducing volume, and improving reliability while minimizing the cost. These fundamental requirements, again, drive our technology to meet key technical requirements. Different format of package material, film or paste, expanding new foundational technologies like resin-based, pure metal, or hybrid materials, and of course, thermal conductivity, and with including our ultimate goal of improving the total cost of ownership for our customer while delivering the key performance target. Again, as a leading material supplier, it's very exciting time for us. I think I said that many times throughout the podcast. And we are actively pushing the boundaries of our portfolio and supporting our customers' long-term roadmap with key innovation along with thermal sintering materials, both in paste and film format. And we're also exploring copper and other precious based fillers technologies to enable next generation needs. And last but not least, we are continuously investing our capabilities across the globe. We are continuously developing our long-standing partnership with key customer and ecosystem partners to enable a strong roadmap of materials to meet the industry requirements.
Well, thank you so much, Burcak, for your time. It was a very insightful discussion. I'm very excited to hear more about the packaging innovations at Henkel. Thank you.
Thank you so much. Thanks for hosting us today.
Thank you very much, Dr. Burcak, for the informative chat. I appreciated your time. We're excited to see Henkel's continued innovations on power modules across EVs, data centers, and industrial electrification. This episode of PowerUp was brought to you by Henkel. If you want to learn more about the Henkel solutions that we've been talking about today, please check out the links on the podcast page at eetimes.com and powerelectronicsnews.com, or the Henkel page at henkel.com. Thank you.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about power electronics. If you are listening to this on the podcast page at eetimes.com or powerelectronicsnews.com, links to articles on topics we have discussed are shown on this page. Power Up is brought to you by Aspen Core Media, and the producer is James Eade.